the same constant rate. If 4 of these machines operating simultaneously take 30 hours to fill a production order, how many fewer hours does it take all the 5 machines operating simultaneously to fill the production order? So there are two ways we can answer this question. One way is, let me show you method number 1 first. We are using the basic unitary method to answer it. 4 machines can do it in 30 hours. And we have to find how many less machines do we need, how many less hours. So let me just, in unitary method, anything that we want to manipulate should be kept on the left, and what is to be calculated should be kept on right. For example, here we have to calculate the number of hours, so we have to keep it on right and write it this way, that 4 machines take 30 hours to fill a certain production. That means one machine will take 30 times 4 hours. Now this is one thing that we need to understand in unitary method. If the number of machines decrease, the amount of time taken will increase because the number of machines and the amount of time are inversely proportional. Now, instead of one machine, we need to use 5 machines. So 5 machines, when they are working together, the total number of hours will be 30 times 4 divided by 5, which is 24 hours. The question is, how many fewer hours? The fewer hours means the old number of hours minus the new number of hours. So earlier we were spending 30 hours, but now there is 24 hours needed. So the fewer hours will be 6, and that will be answer C option. That's method 1. Now let's talk about method 2. Method 2 is about developing an understanding. I have developed it many times in many questions. So once again, let me explain. We often deal with these 3 variables. One is M, which is manpower or the machine power. Manpower or machine power. That means the number of men, the number of machines needed to finish the work. W is the amount of work that needs to be done. And then the last thing is T, that is time to finish the work. Now we need to understand that what kind of relationships we have. Men and work are directly proportional, because if work increases, the manpower also needs to be increased, or if the work decreases, the manpower also needs to be decreased, keeping the time constant. When we talk about any 2 variables, we keep the third variable constant. So greater work requires greater manpower to be done at the same time, and less work requires less manpower to be done. Therefore, they are directly proportional. Likewise, manpower and time are inversely proportional, because if you reduce the time, then the manpower needed to finish the work, the same work, will be greater, or if you have greater amount of time, then less manpower would also do. Now we combine the 2 things and we come across a relationship M is proportional to W over T, which when we simplify becomes M is equal to K times of W over T, where K is the constant of proportionality, and we get M into T upon W is equal to constant. This is one relationship that we are supposed to use here, and very easily we can answer the question using this. How do we use it? Basically, this ratio remains constant. That means in the first scenario, the ratio M1 T1 over W1 will be same as M2 T2 over W2, provided we have same kind of work, same kind of machines used. Now, in the first case, there are 4 machines used. Time is 30 hours. The work is 1. In the second case, 5 is the number of machines. The time taken is, let's assume, is T2, and work is the same. When we simplify this, T2 becomes 24. That means the total number of less hours needed will be equal to 30 minus 24, so that gives us 6. After this step, the process is same, only I wanted to explain this expression, which is quite useful in many questions, and it completely eliminates the need of unitary method in the work rate question. If you like the video, please click the like button, subscribe to my YouTube channel, and thank you for watching this.